Hello and welcome to Solving One Variable Equations, Lesson 2.01. Today we're going to be solving equations that have one variable, and as a short reminder, a variable is any letter that represents an unknown number. Most commonly we see x's, but we can use any variable that we like, A's, B's, C's, Z's, you name it. So today, our objective is when we're done going through this video and you're done watching it, you should be able to say, I can create equations with one variable and solve them. This is the foundation for the rest of not only this algebra course, but you will use these skills in geometry and you will use them in the following algebra courses that you will be taking. So as a brief review, there are 4 basic steps to solving equations. First, we want to distribute if necessary. So distributing is when you have a number outside of a parentheses and you multiply what is inside the parentheses by everything that's on the outside. So in this case, we have 2x plus 8. Sometimes we might even see a problem that looks like this, where you have 2 binomials. So a binomial is a term that has, it's a group that has 2 terms. So x plus 1 times 2 plus 3. If you saw this in an equation, you would want to multiply first. After distributing, we want to combine like terms. So that is where you are taking things that are the same, such as 2 x's and 3 x's. We want to combine those to make 5 x's and any whole numbers. 2 plus 3 is 5. The reason we combine like terms is it makes the problem much easier to manage. Then we want to get the variable on one side of the equal sign. So if we have 2x is equal to 3x plus 4, we want to get all of the variables on one side. So we subtract, and I'm going to move my 4 over, and we see that x is equal to -4. And then we want to isolate the variable. And that means when we have a problem like this, after we've done all of the other steps, we need to get this variable all by itself to figure out what number it represents. And when we're multiplying, the opposite of multiplying is dividing. So 12 divided by 2 is 6. So our 4 steps: distribute if necessary, combine like terms, get the variable on one side of the equal sign, and isolate the variable to find out what number x represents. Let's look at some problems. Our first problem is 41 equals 12d minus 7. When I go back to my instructions, I don't have any distribution that I need to do, but I do need to get like terms together. So I do that by drawing a line down the equal sign. That line is to keep you organized, and it also helps us to make sure that we are keeping everything balanced. I have a whole number here, 41, and minus 7 on this side. So I need to combine those two numbers. I'm going to move the 7 over. And when I do that, I change the sign. And what I do on one side of the equal sign, I do on the other. These cancel out. 41 plus 7 is 48. And I bring down the 12D. Now I have a coefficient, which is the number that comes before a variable. When they are side by side, they're multiplying. So again, I'm thinking in terms of opposites. How do I do multiplication to get the variable all by itself? I'm going to divide by 12. And why 12? Because I know that 12 divided by 12 is 1. And that leaves me with the variable d. What I do on one side of the equal sign, I do on the other. 48 divided by 12 is 4. So my variable in this example is d is equal to 4. Well, I want to make sure that I did my math correctly. So I take this information, and every place that I find a d, I am going to replace that d with the number 4. So I rewrite the original problem, 41 times 2 times d, which I now know is 4, and I rewrite the original problem. This is called my check, and it makes sure that I know what I'm doing with my math and that I haven't made a mathematical mistake. And that should be a 12 times 4, not a 2 times 4. I draw my equal sign. I extend that. 12 times 4 is 48, minus 7. I end up with 41 is equal to 41. 48 minus 7 equals 41. Ta-da! It checks. There we go. Let's do another problem. And I really hope that you are taking notes so that you are practicing this as I work through these problems. Math is very much a hands-on subject, and it's not enough just to watch me solve the problems. You need to be doing it with me. Okay, so we have 18 is equal to 4a plus 10. I'm going to draw my line that aligns with the equal sign. Once again, I notice I don't need to distribute, but I do have numbers on either side of the equal sign. I'm going to move the 10 over here, and I'm moving the 10 because where I can, I like to keep numbers positive. Sometimes you can end up with negative numbers, and we frequently do. But if I have a choice, just like you, I like positive numbers. So I'm going to take 10 away. I do the opposite of the add sign, which is subtraction. And I take 10 away on both sides, which leaves me with 8 is equal to 4a. Now the 4 is multiplying with the a, so I'm going to undo that by dividing. I divide both sides by 4, and I know that 4 divided by 4 is equal to 1a, and 8 divided by 4 is 2. So I now have a value or a number for the variable a. Let's check it. So I rewrite the original problem. 18 is equal to 4 times 2 plus 10. This 2 is the number that I figured out previously that a was equal to. I draw my organization line. I know that 4 times 2 is 8 plus 10, and I can see that 18 is equal to 18, and it checks. Ta-da! Did it! All right, we've solved 2 problems. And we've done it correctly, and I know it's correct because I've gone back and checked. The importance of checking is it verifies that we've done our math correctly. If we haven't, then the problem itself will not work. Now here I have a problem. I'm looking at the top one here. In fact, I will cover up the bottom one, where I see that I have distribution. I have a number outside of some parentheses, and when they're side by side, this tells me that I'm going to be multiplying the 3 by everything that is on the inside of the parentheses. So I draw my organization line. I know that 3 times x will be 3x. And then 3 times 1 is 3. And as I travel over to the right side of the equation, I notice that I have a negative 2 times x and negative 2 times negative 1. So negative 2 times x is negative 2x. That's this part. And then I'm going to multiply it by the second number. And I know that when I multiply 2 negatives together, it gives me a positive. And I bring the 6 down. When I look at the right side of the equation, I notice that I have 2 numbers here. So to help me simplify the equation, I need to combine like terms. I cannot combine them with the 2 x's because I don't know what x is. But I recognize that 2 and 6 is equal to 8. So I write that down. Alrighty, so now we're at a place where I have x's on both sides of the equal sign, and I have whole numbers on each side of the equal sign. So we're still going to continue our combining of like terms. I'm going to move the 3 from the left side to the right side. When I do that, I have to switch the sign, and I move the 3 directly under the 8, since those are the numbers that I will be combining. Now with the negative 2, since it's a negative, the opposite of that, because we have to stay balanced, is positive. I'm adding. And I'm going to add 2x directly to the 3x. So when I do that math, 3x's plus 2x's is equal to 5x's. I realize that the 3's cancel each other out. The 2x's on this side cancel out. Then 8 minus 3 is equal to 5. I'm getting close, almost done. 5 and x are being multiplied, so I'm going to divide each side by 5. And 5 divided by 5 is 1. So x is equal to 1 in our problem. Well, like a good mathematician, I am going to verify. And I will do that by taking this x, and so x is 1. I'm going to rewrite the original equation, replacing this x with the number 1. And I do that on this side of the equation as well. Every time there's an x, I substitute it with a 1. Using my order of operations, I solve my parentheses first, and I recognize that 1 plus 1 is equal to 2. And on the other side, 1 minus 1 is 0. So I'm left with 3 times 2 is equal to negative 2 times 0 plus 6. 3 times 2 is 6. I know that anything times 0 is 0, so I can cross that out, bring the 6 down. I have 6 is equal to 6. Yay, I did my math right, and I hope you did too. So moving on to the next problem. And what I'm trying to do, and I realize I'm going fast, so please do go back and rewatch the video, rewind it, because I want you to be able to understand this material. It's super important. Here we have another distribution problem. So I have negative 2x minus 6 is equal to minus 2x minus 2 minus 4. So the 2x is here, negative 2 times 3 is negative 6. And on this side, I have negative 2x, negative 2 plus 1 times a positive 1 is negative 2, and I bring the 4 down. I'm going to combine like terms. Negative 2 minus 4 is minus 6. Now I'm going to move my x's from the right side of the equation to the left side. And I'm going to move my 6's over to the right side. So I add 6 to both sides. Now this is an interesting problem because when I combine negative 2x plus 2, positive 2x, I end up with a 0. And negative 6 plus 6 is also equal to 0. And I notice that I have the same thing on the right side. So 0 equals 0. So the question is, what is x? I don't have any left. In a problem like this, x is equal to any number. In this particular problem, x is equal to any number. Well, how does that work, you ask? Well, I'm going to pick a number. How about if I pick the number 5? So I'm going to say that x is equal to 5. I'm going to substitute 5 into the area where each x is. So I rewrote the equation, substituting 5 for the letter x on both sides. Now I distribute. So minus 10 minus 6 is equal to minus 10 minus 2 minus 4. So minus 10 minus 4 is negative 16. Negative 10 minus 2 minus 4 is also equal to negative 16. X can be any whole number. It can even be a fraction. The reason this works is because this equation is equal to this equation. They're equivalent. That is why it works. So should you see a problem like this on a test, I want you to recognize when you have whether you're doing a fill in the blank or maybe a multiple choice, x can be absolutely any number that you can think of. And when you substitute it into these equations, you will always come out with the same number here at the bottom. So a little trick problem, but I want you to be able to handle it. and I'm confident that you can. Alrighty, just a few more problems here. So here we have x plus 20 divided by 2 is equal to 3x. X plus 20 in parentheses divided by 2 is equal to 3x. I recognize that I'm dividing, and I want to get rid of this division. The way I do that is I ask myself, what's the opposite of dividing? It's multiplying. So I'm going to multiply by 2. Remember, the numbers are always given to us. So if I multiply this side by 2, I'm going to multiply the right side of the equation by 2 as well. Draw my handy dandy organization line. I know 2 divided by 2 equals 1. So I'm left with x plus 20 is equal to 6x. 2 times 3 is 6 with the x. Wow, that looks a whole lot simpler, doesn't it? Remember, this is a division problem. When you have parentheses, you can multiply it by the number that's in the denominator. And you have to multiply both sides, and voila. That is how you undo a fraction. Now I have x's on both sides of the equal sign, so I'm going to move the 1x over. I bring the 20 down. 6x minus 1x is equal to 5x. I'm going to divide both sides by 5. 5 divided by 5 equals 1x, and 20 divided by 5 equals 4. I go back to my original problem because I like to get my answers right. I don't like wrong answers. So I'm going to substitute my 4 in here. So 4 plus 20 divided by 2 is equal to 3 times 4. This is where the x's were in the original problem. 20 plus 4, use PEMDAS, 20 plus 4 is 24. I'm still dividing by 2. And 3 times 4 is 12. 24, or half of 24, is 12. 24 divided by 2 is 12. And I already had 12 on the other side. They check. So voila, we've done our math correctly again. Remember, when you see a problem that looks like a fraction, the way to undo it is to multiply each side by the denominator. And that will give you a more regular looking problem. So always think, what is the opposite of what I'm being presented with? All right, a couple of story problems. So we have a rectangle, and it has a perimeter of 125 centimeters, and there's a width of 5 centimeters. So the instructions are asking us to write an equation and solve it to find the length of the longest side. Wow, okay. So I have to both write an equation, and then I have to figure out the length of the longest side? Oh goodness. Well, the first thing I like to do, I like to draw a picture. And you're probably asking me why I like to do that. Well, pictures help me to make sense of the problem. So I know when I go back up to my original information that the rectangle has a perimeter which is the distance around, of 125 centimeters. And the width is 5 centimeters. So I'm going to label 5 here because I know what that is. And I know that on a rectangle, the ends are the same. So both of those are 5. What I don't know is the length. So I'm going to assign a value of x. It's an unknown variable, unknown number, and an x. And I'm going to start here. And I know that the perimeter is going to be 5 plus x plus 5 plus another x. All of that is going to add up to 125 centimeters. Okay, this is looking more familiar. I need to combine like terms. So 5 and 5 is 10, and I have 2 x's. 1x plus 1x equals 2 x's. And I now have a combined equation that reads 10 plus 2x equals 125. Oh, cool. I was asked to write an equation. Check. There's my equation. 10 plus 2x equals 125. Okay, well, I'm not quite done, am I? Because I have to find the length of the longest side. No problem. All I need to do is solve for x. So I'm going to combine like terms. I'm going to move my 10s together with the 125. 125 minus 10 is 115. I'm going to divide each side by 2. And I know 2 divided by 2 is x. And if you know what 115 divided by 2 is off the top of your head, go ahead and answer it. Every so often, I use a calculator and it is okay. So 115 divided by 2 is equal to 57.5. I have now found the length of each side, or how long the length is of this rectangle. And when I add all of these together, I know that 2 times 57.5 is 115. I have 10. Originally, I'm left with 125 equals 125. Cha-ching. And watch your labeling. So the length of this rectangle is 57.5 centimeters. Nice. Let's do one more problem. It's really important that when we're doing math, the reason why we do so many story problems is that math exists everywhere in our daily lives. And when we can understand that and be able to apply those concepts, then we're able to do our own problem solving within whatever we're trying to figure out. Maybe we're trying to figure out how to build a house, or a sandbox for our baby brother, or maybe we're going to build a ramp for our skateboard. To do all of those things correctly, we have to use some math, and this is a way to do that. Now in this particular problem, we have Eddie, and Eddie has saved $45 to buy a skateboard. Now because he lives in Washington, he also has to pay sales tax. Whoops. And the sales tax is 7% of the sticker price. So we're asked to write an equation to show the highest price that Eddie can spend. Oops, not on his camera. He's not getting a camera, he's getting a skateboard. Okay, so we know that whatever combination of original price, Eddie only has $45 to spend. So since I don't know exactly how much he can spend, I'm going to call that X. That is the price of the skateboard. Now, in addition to the price of the skateboard, because he lives in Washington, he has to pay 7% tax. So I'm going to multiply 7% times the value of that X. And that will equal $45. Well, I have two X's here. I have 1X plus 0.07X. That equals 1.07X is equal to 45. Well, we've been in this place before. Going to divide each side by $1.07 because I need to get the X by itself. And using a calculator, use your tools. 45 divided by 1.07 is equal to $42, and I'm going to round up, 42.06 cents. $42.06. So if I replace, I do my check, 4206 plus 0.07 times 4206 is equal to 45. So I end up with 0.07 times 4206 is 294 plus 4206. And that equals $45. So the highest price that Eddie can pay for his skateboard is $42.06 because he has to be budgeting for that extra sales tax. And he can spend any amount less than $42.06, but that's the max he can spend and still stay within his budget. So this is how you solve one-step equations, or equations with one variable. So when you're doing that, as a reminder of our 4 basic steps, when necessary, you distribute first, then you combine like terms. That's all things that are the same, all the variables that are the same, all of the whole numbers that are the same. You get the variable on one side of the equal sign. So if the variables are on both sides, you have to pick a side so that they're all together. And then you need to isolate the variable. So if the variable is being multiplied, you need to divide in order to get that variable all by itself. So these are the 4 basic steps to solving equations with one variable. It is now time to move into the rest of the body of the lesson. Please watch this as often as you need to, and go ahead and take your quiz, and I wish you the best, and I think you're going to be highly successful.